Hello, everyone. Our group was on the ubiquitous market prediction project. Here's the content of our presentation. Let's start with the introduction. Regardless of your investment strategy, fluctuations are expected in the financial market. Despite the variance, professional investors try to estimate their overall returns. Risks and returns differ based on investment types and other factors, which impacts the stability and volatility. The data set of a competition contains features derived from real historic data from thousands of investments. Our challenge is to predict the value of an obfuscated metric relevant for making trading decisions. And this is a forecasting competition where we need to use the trend data set to predict the return. The trend data set contains the following features and the target to be predicted. One is the row ID, and the other is the time ID, which is the ID code for the time and the data was gathered. And another ID attribute is the investment ID. It is an ID code for investments. And in total, we have 300 anonymized features generated from the market data. In total, we have over 3 million samples and 304 features to be used. Here's a plot showing the number of row IDs for each time ID entry. And in total, we have 11 unique time IDs and samples. And this plot shows the relationship between investment IDs and the number of entries in each investment ID. And in total, we have over 3,000 unique investment IDs and samples. And now let's describe the model structure. And our group mainly used the TabNet for competition. It is a new canonical DNN architecture for the tabular data, and it combines the DNNs with decision trees. And here are the benefits of using TabNet. And one is that it doesn't need to do any pre-processing for the tabular data, and it is trained based on a gradient descent optimization. And this enables flexible integration into end-to-end learning. And second, it uses sequential attention to choose which features to reason from at each decision step. And third, TabNet outperforms other tabular learning models on various data sets in different domains. And finally, the TabNet has two types of interpretability. One is the local interpretability. It visualizes the importance of features and how they are combined. And another one is the global interpretability, because global interpretability quantifies the contribution of each feature to the trend model. And here's the structure of the TabNet. It is for the TabNet encoder, it is composed of a feature transformer, an attentive transformer, and a feature masking component. There is a split block which divides the processed representation to be used by the attentive transformer of the subsequent step as well as the overall outputs. And for each step, this feature selection mask provides interpretable information about the model's functionality. And the mask can be aggregated to get the global feature importance attribution. For the decoder, it has a feature transformer block at each step. And now I will present the experiments. We split the data set based on the timestamp, where the instances whose time IDs are smaller than 11 to the 6 are in the trend set, while the others are in the test sets. For the evaluation metric, we use the person correlation coefficient, where the formulas are shown here. Here are the hyperparameters we use for the TabNet. For example, for the width of the decision prediction layer, we use the value as 8 and so on. For the masking function for selecting features, we use the int max we use the int-max function. And for the optimization, we use the Adam algorithm with 0.0249 learning rate. And here are the baselines we use to compare with the TabNet. One is a linear regression, the other is a light gradient boosting machine. And the final one is the MLP plus CNN ensemble. And the main results are shown in this table. All results are obtained by 3 repetitive experiments under 3 different random seeds. We have the following observations from the table. One is that TabNet outperforms all baselines on both training and test sets. And another one is that standard deviation of the TabNet is small compared with LGBM and MLP plus CNN baselines. And without using any ensemble techniques, TabNet still outperforms the ensemble baseline. And now I will present some hyperparameter analysis. First, we analyzed the number of decision steps for the TabNet. It specifies how many times the TabNet will process the features in the encoder and decoder. As shown in the figure, when taking 3 decision steps in the encoder and decoder, a TabNet has the optimal performance. And the performance will drop monotonically when increasing the number of decision steps starting from 3. And the performance in 6 steps is even worse than in the 2 steps. Another hyperparameter we analyze is the sparsity regularization coefficient. It specifies the strength of the sparsity regularization loss in the TabNet optimization. And the performance of using different values of these hyperparameters are shown in this figure, where the blue bars shows the performance on the train set, and the orange bars shows the performance on the test set. And we have the following observations. One is that the instance with the coefficient of value 0.001 has the optimal generalization capability. And the gaps between the train score and the test scores are in this range. And the values will decrease monotonically as the coefficient increases. And last, I will present some feature importance analysis. Really select these 3 features from the data sets and then remove each of them. And the performance are shown in this table. And we can see that all 3 features has positive contribution to the performance of the model. And the feature number 2A4 has the greatest significance. And for those features without significant influence, it might be helpful to remove those features or aggregate them into one single feature to reduce both time and memory consumption. And in conclusion, we introduce the competition and we present some data analysis and visualization of our data for our projects. And next, we explain the TabNet structure and its functionality. And in the experiments, TabNet outperforms all the baselines. And finally, we analyze some important hyperparameters and the importance of some features for the TabNet. Thank you.